In previous chapters, all the algorithms examined were simple and expressed in a single program. Very few real programs are that straightforward. Most programs are long and complex. A typical working program consists of several hundreds of statements, and it becomes essential to break the entire program into smaller modules. It is not always easy to consider all the simultaneous tasks a program has to perform when writing a program. Instead, it is easier to divide the program into major tasks and subtasks. This decomposition is required for ease of understanding, efficiency of operation, and maintenance. Top-down design or functional programming refers to the identification of tasks and subtasks in a program. This process divides the program into modules that are separate and workable sections. Modules are further divided into sections called procedures. Each procedure is responsible for a specific task. These procedures are also called as subroutines or subprograms. It is a small part of the main program. Generally, a major problem is subdivided into functionally different modules. A separate program is written for each module. Finally, when all the modules are coded, they are integrated into one program. Each subroutine is functionally independent. This method of breaking a problem into a number of functionally independent modules is called the top-down decomposition. Each subroutine contains only statements that allow it to perform that task. Procedures are given meaningful names that describe the tasks they perform. A popular technique for decomposing a program into routines is top-down decomposition. It is characterized by moving general statements of what the program does to detailed statements about specific tasks that are performed. Starting at the most general level possible usually means starting at the main routine in a program. Here are some things to keep in mind as you do a top-down decomposition. Design top levels first. Formalize each level. Verify each level. Move to the next lower level to make the next set of refinement. The guiding principles behind top-down decomposition is the idea that the human brain can concentrate on only a certain amount of details at a time. If you start with one general routine and decompose it into more specific routines step by step, your brain isn't forced to deal with too many details at once. This approach is called divide and conquer. Continue decomposing until it seems as if it would be easier to code the next level than to decompose it. A program divided into procedures will execute each procedure as it is required. The mainline performs this function. It ties all the procedures together and provides master control over them. The mainline shows the major tasks that a program needs to perform. It should be logical and easy to read. The mainline controls the execution of a required procedure by naming it. This is known as calling a procedure or invoking a procedure. A calling procedure calls another, and the called procedure starts executing. Once a procedure has been called, control of the program passes to the procedure. When the procedure is executed, control passes back to the main line. When there are no more statements to execute or procedures to call, the program ends. Once data has been processed in a procedure, it may need to be passed to another part of the program. If the same variable is available throughout a program, the variable is called a global variable. This is because it is known to the entire program. Any procedure can access or modify this value, and it will be reflected in all the procedures. Local variables are only used within a procedure. They are not known to the rest of the procedure. The scope of a variable refers to the parts of a program that define it or refer to it. The whole program is the scope of a global variable. A local variable's scope are the procedures that refer to it. Side effects occur when a procedure passes a global variable to another procedure. Side effects can cause confusion because it can be very difficult to identify the procedures that are changing variables. This can make maintaining and debugging code very difficult. During declaration, the prototype of the procedure is given, where all the required arguments are mentioned. The variables used in the prototype are formal arguments. When a procedure is invoked, the required arguments are passed along with the call. These arguments are known as actual arguments. Parameters, actual arguments, are used to solve the problem of side effects of local and global variables. A parameter is a variable or constant that communicates between parts of a program. Parameters provide a way to control the procedures that refer to and change variables. Parameters are passed from a calling procedure to a called procedure to be processed, and then they are passed back. A parameter can also be passed to the called procedure for processing and not passed back. Called procedures can also pass a parameter to a calling procedure for further processing. The parameters used by a procedure must be listed by both the calling and the called procedure. When a procedure returns a parameter to the called procedure, it is referred to as the return value. In a pseudocode, the parameter names would be placed in brackets after the procedure name. In Pascal, parameters are listed in brackets after the procedure name. The variable pay is a parameter that will be used by the procedure called calculate_pay. We will now write the pseudocode for a program that will accept two numbers and calculate the sum, difference and product of the two numbers. It should also display the result of the calculations in each case. Instead of writing a single block of code to perform all the operations, we shall use three different procedures. In the main program, we will simply call each of these procedures to perform the necessary calculation. In the main program, we accept two values from the user. Then we call the procedure sum, passing to it the two values. When this statement is executed, control passes to the sum procedure. This procedure calculates the sum of the two numbers and displays the result to the user. When the return statement is executed, control passes back to the main program and execution continues at the statement following the procedure call. The next statement is executed, which calls the sub-procedure, passing the two values to it. This procedure calculates the difference between the two numbers and displays the result. The return statement causes control to be returned to the main program. The next statement in the program is executed, which is a call to a procedure multiply. This procedure calculates the product of the two numbers and displays the result. The return statement passes the control back to the main program. There are a number of criteria available to a programmer for decomposing a large program into smaller modules or procedures. Some of these criteria are as follows. The purpose of the programmer's code is not only to instruct an electronic device on how to solve a problem, but also inform the future programmers how the problem is solved. If a programmer other than the one who wrote the algorithm is not able to understand the code, the program will become a liability rather than an asset. Each of the program modules should deal with a single task, and it should have a single entry point and a single exit point. A single entry point module is one where the control can only enter at one location in the algorithm, which is usually the beginning. A single exit point module is one in which the control can only exit from one logical point within the algorithm. If a maintenance programmer is able to understand what a program does and how it is done, the task of maintenance is much simplified. Each module or procedure must relate to a single self-contained task. Each module must be self-explanatory in its operation by including sufficient comments. Each module must do its own task and nothing more. Many programs contain functions that are common to a number of separate tasks. Any task that is performed more than once in a program should be the subject of a separate procedure. This procedure must be written in a sufficiently generalized manner so that it applies to all situations. Tasks are not only commonly repeated within one program, they are common to a number of programs. The extension of the principle of making it reusable in a single program is that of making it reusable among several programs. Basically, there are two types of procedures, recursive and reentrant. Recursion is a method or logic by which the procedure calls itself repeatedly. Recursion may be direct in the case of a procedure calling itself explicitly, or indirect by a procedure calling another, which then calls the original procedure. Each time the recursive algorithm descends one further level of recursion, it must save the environment in which it was operating and restore it upon return to that level. This environment includes the variables that the algorithm was manipulating and the address to which the procedure must return upon exiting from that level. Reentrant procedures, sometimes called pure procedures, are programs or program modules that do not alter their instructions in any way during execution. Hence, they may be simultaneously called by a number of other programs. If this simultaneous calling occurs, the reentrant procedure need be in the memory only once. Reentrant procedures will normally store all changing data within a user's working space. This means that each serviced user is a self-contained entity which can be picked up and discarded as often as needed.